Okay, yeah, that was dumb. I'm sorry about that, kids. I just copied the problem wrong. The longest leg, I was right about what the longest leg was. It's just supposed to be 6, not 10. This is 10, the height. Okay, so back to the drawing board. That's supposed to be 6. Now you're going to see this twice. This is 6. This side here is going to be 6 divided by the square root of 3, which is 6 square root 3 over 3, and the 6 and the 3 cancel. This is 2 square root 3. See, much nicer numbers. Oh, this is so much better. I actually deleted the work I done on the last one, so you're not even going to see that in hard copy. It's just on that one part of the YouTube video, and then it'll be gone forever. Okay, so lateral area is perimeter times height, and area of the base is half times base times height. Of course, these are different heights. All right, perimeter of the triangle is 6 plus 2 square root 3 plus 4 square root 3. I'm supposed to take all of that times the height of the prism, which is 10. Area of the triangle is half times base times height, and base times height in the triangle, I'm going to use this, 6 and 2 square root 3. Okay, that's easy. That's, whoops, I don't know if it equals there. That is 6 square root 3. Wow, this is better than last time. This is 6 plus 6 square root 3, and all of that still times 10, which is just 60 plus 60 square root 3. And I'm adding on another 6 square root 3. Wow, no fractions. Life is good. Which is going to be 60 plus 60 is 6 square root 3. Okay, so that's that. Exact surface area. That has the base. That's everything. Indicate units. Centimeters. And we are in squared because we're talking about area. Exact volume. It's going to be easier. Area of the base times the height. Area of the base I've already done. It's that. I guess I didn't need to draw a box around it, but now you know what I'm talking about. That's the 6 square root 3 times the height of the prism, which is 10. So this is just 60 square root 3, which is also part of the lateral area, but that's just sort of a coincidence. And this would be cubic centimeters. Okay, I feel better. Okay, next I think actually the most important, valuable, applicable thing to do is probably more like page 2. I know the answers to this are at the bottom of page, I don't know, 4 or 5 or something. But a lot of people are still not sure how to get these in class. Because the next thing I was going to do beyond the last problem I did was where things start to get kind of crazy. Or I guess I should say less test-like than this stuff. So here we go. We have a sphere. The volume of this sphere is 256. I'm going to move that up. Volume of this sphere is 256 cubic meters. And I know what that equals in terms of formula. 256 is supposed to equal 4/3 pi r cubed. I just can't help but write that now. I don't even know if I need that. I bet I do. And the cube has the same volume too. And that's going to be, you know why we call it cubing. If I call this side x, they're all x, it's a cube. And this volume is just that. Okay, the question is, which one has the greatest total surface area? Yeah, so I'm going to need this radius. I'm going to need this side, all that kind of stuff. Let's do one at a time. If 256 equals 4/3 pi r cubed, the first thing I'd probably do is divide both sides by 4/3, and people are having trouble doing that. 256 divided by 4/3, I don't care how you do that on your calculator. Multiply by 3 and then divide by 4. Fine with me, but you should get 192. All right, then the next thing to do is divide by pi. And that's no picnic. You get that calculator divided by pi, I get 61 point something something something. And then I got to take the cube root of that to get radius. And that is, I'm leaving the answer in my calculator. I'm going to say, give me the cube root of that exact, this number of pi. It's really close to 4. It's 3.939. I'm going to say. It's not exactly, but it's kind of close to that. Okay, so then I have the cube root of 256. That's a nice number, right? Yeah, wait, I did that wrong. 256 to the power of 1/3 is, no, it's not a nice number. You'd think 256 is a nice number. It's not. The cube root of 256 is actually something like 6.35 almost. I'm stopping there because it's a nice close thing to round to. Okay, let me make a separation here. The surface area of this thing is 4 pi. Oh, why didn't I leave that in my calculators? Radius squared. If I take that radius, 3.939, It's actually 898,0087 something. I'm going to square that times 4 pi. I get something like 194. Yeah, I'm really not happy with that being equal. 194.97. It's almost 195. Surface area here. Now you could do the lateral area plus 2 base thing in your book, but I like 6 squares on this. So let's go 6 times 6.35 squared. You're going to end up getting the same thing, and that is about 6.349604 blah 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 squared times 6. I get 241, and you would guess this to be more than the sphere. 241.905, something like that. It's something like that. Okay, great. All right, will this sphere fit in this box? This sphere has a bump on it. No, this sphere has a, kind of looks like a face with a nose sticking out. This sphere has a surface area of 1,024 pi. Well, immediately, you know, you got to figure out, okay, that means they're probably going to ask you for the radius, or you're going to want to know what the radius is. So if that's true, then divide off the 4 pi. 1,024 divided by 4 is a nice number. It's 256. Oh, there's a 256. This is why we like 256, is because it's a square number. The radius of that thing is 16. Is it going to fit in this box that has a side of 30? Well, it's got to fit in there. It's got to fit between here and here, or, you know, between the front and the back. Well, how far is it from here, excluding the lump? the distance across that thing, if the radius is 16, the distance across that thing is 32. No, it will not fit. It is too wide to fit in a box that's only 30 wide. Now, if you melt this thing down, certainly it will fit in the volume of this box, but the question is, can you fit physically this ball inside this box? No, it's too skinny. I'm going to skip around a bit. I figured this is probably the last video I need to make. It's getting a little bit later in Sunday afternoon. Again, if you email me, I'll take requests between now and when I go to bed, but judging by the view count so far, I don't think people are rushing right now to study this, and I think that means I've made enough to keep you occupied. All right, so that's why I skipped into this one, because those last two I really help people with in class, and there was not a lot of confusion on this. So I think this is the next best one to do. Supposed to find the surface area and volume of this thing. They gave me this weird diagonal measurement. So if you do Pythagorean theorem on this, you'll find out this is a 3, 4, 5 triangle. This side will have to be 12, and that's kind of the new sort of trick here. The surface area, let's do lateral area plus 2 bases. I'll call the base the side it's sitting on. Why not? Be least confusing. This is the perimeter times the height. This is 2 of these faces that are, just to solidify what I mean by base, it's the 12 by 20 side. The perimeter of the 12, 20 side is 12 plus 20 times 2, which is 64, times the height. It's amazing people are getting the perimeters wrong. This will be 480 plus 64 times 9. I get a total of 1,056. Volume is area of the base times the height. The base is just a 12 by 20, or you know it's length times width times height kind of thing. And I get 240 times 9, which is 2,160. Done. Looked like the next one I skipped there was actually one I did on another page anyway. Same numbers. It was the one I made a mistake on. It's actually in 2 places in your packet, apparently. Anyway, semicircular trough. Looks like it's upside down. No big deal. They didn't really connect this. I don't know if this helps you imagine what the thing looks like. But it's like half of a cylinder. It's been chopped in half sort of the long way. Find the exact volume, exact surface area. Well, the radius here would then have to be 1. Surface area we'll find as, because this is like a cylinder. It's like a prism. You got 2 congruent bases, everything in between. So we could still call this actually lateral area and 2 bases. But the lateral area is kind of interesting because it's like the distance all the way around this thing. You know what? I don't like it. Let's not do it that way. We could, but let's just think of this as 3 parts. Let's think of this as rectangle on the bottom plus roof, the way it's sitting. It's like that curvy roof thing, plus 2 semicircles. I think that'll be easier to build in terms of surface area. The rectangle on the bottom is 2 by 5. See that how easy that is? I started thinking about this way, and that was the part I skipped, and I didn't like that. You probably want to see 2 by 5. The roof part, well, that's a rectangle if you flatten it out, and this would be one edge of the rectangle. The other edge would be this 5. So it's 5 by, well, half of a circle, radius 1's circumference. Circumference would be 2 pi r. Radius is 1 again, which is 2 pi, but that's the whole circle. I don't want the whole pi. I'd rather the whole pi. I don't want the whole circle. I just want half of it. So that little length there is just pi. That's an arrow. Okay, great. So pi is the length of that plus 2 times the area of that, which is like saying, well, I'm not going to call it 2 times the area of that. We'll call it we'll call it 1 full circle. And the 1 full circle is pi r squared, and the radius is 1, so that's really just pi. So I have 5 pi plus another pi, that's 6 pi, and this is 10. Volume is area of the base times the height. Area of the base is half of this circle. It's half of pi r squared times the height of the whole thing, which is 5. So that's 5 pi over 2. Really small, actually. Okay. Okay, this is a little bit non-standard. It's about throwing this rock into this tank and then how the water goes up 0.5 centimeters. That's not very much. I'm writing really small. It goes up 0.5 centimeters. So basically, the rock's volume, once it goes down here to the bottom, it makes the water rise by a certain amount. This is like adding one great big slab of really thin slab of water across this, spread across this whole top surface by a height of 0.5. The volume of the rock is equal to the volume of the sort of slab of water that it produces, that it adds to the rising water there. So we're looking for the volume of a little prism here that's 0.5 high by 30 by 45. The little height here makes no difference at all, actually. This could have been 100 meters deep. If it goes up by 0.5, it's raising it. Of course, it's raising it on the surface of this area. So that whole thing, 30 times 45 times half, that's 675. Exactly. Done. All right, I picked this one because it's very test-like. You're welcome very much. All right, so it's about this block thing with a hole drilled out of it. That looks like a 15 and a 25 and a 24. Sorry, I can't keep that font very clear for you, but you have the printout in front of you. The cylinder has a radius of 6. Of course, they don't write that in. And the dimensions of the cylinder are 24, 25, 15. Oh, thank you. Find the volume of the surface area. Well, the volume you know is going to be easy. Volume, all I'm going to do is take volume of the box minus the volume of the cylinder. If you were building this out of Play-Doh, that's what it would feel like. You had so much Play-Doh and you removed so much and that's it. Surface area is a whole different question. Volume of the box is simply 25 times 15 times 24. You want to call that area of the base times height, feel free, but that's how you find the volume of the box. Volume of the cylinder is area of the base, pi r squared, times the height of it, which is 24. So I have 25 times 24 times 15, which is 9,000, nicely enough, minus, that's a minus, minus 6 squared times 24 pi, which is 864 pi. Does it say exact? I kind of wish it did, but it doesn't. 9,000 minus 864 pi is about, if you really cared to have this as one approximated decimal, it's 6285.7 or so. Okay, surface area is going to be weird. Let's do, all right, we have 2 of this face, which is like square minus a hole. We're going to have base, I'm going to call that base because it's on the bottom, minus hole, and there's 2 of those. Plus, and then what's left here, we have the 4 outside walls of the box. I'm going to call that lateral area of the box. Plus, I'm not done yet. Okay, so I had these flat gray faces here, flat gray face here. Outside big walls, fine. If I still had to paint that, I'd have everything painted except for the inside of this hole. The inside here, this sleeve that goes all the way down, this needs to be painted also on the inside of it. It has a surface area. It looks like the lateral area of a cylinder. It is exposed. So all of this counts in the surface area. Okay, I'm running out of time, so I'm going to do this kind of quickly. Area of the base was, those were 25 by 15s, minus a 36 pi, and there are 2 of those. Gosh, that takes forever when I'm in a hurry. Lateral area of the box is its perimeter times its height plus the lateral area of the cylinder, which is 2 pi times radius times the height. A little bit of calculation now. I get that, and then I can combine these 2 terms, and I get 2,674. And I can also combine the pi terms. Now, careful, that's a negative 72. I have 216 pi that I'm adding to that. So there's the exact answer. Then I can approximate that. And I think I'll stop there unless I hear from any of you. Good luck studying tonight. I will see you tomorrow.